Okay, in this example, I'm going to show you how to find estimated standard error of the sample mean given the sample size and sum squared. Remember, this is not a standard deviation. This is the sum squared. So what is the formula for estimated standard error of the mean? This is what question is asking. So you're going to given a formula table and that has this kind, this is the word is going to be written in the formula table. Okay, well, we have at least two formula for that one actually. Well, I shouldn't say two formula, one formula in two different ways. Okay, but technically both of them are same actually. So well, one is here, estimated standard error of the mean, S sub m is sample mean. Okay, estimated error of the mean is equal to standard deviation over square root of sample size. So that is one of the formula. Or there is another formula. What is the another formula? Same thing, estimated standard error of the mean, which is S sub m sample mean, as you see down the estimated error of the mean, is equal to big square root here variance over n. That is another formula. Or this is another way of writing the same formula. Now we have to look into the formula. What is given? For example, sample size is given here. If this was a standard deviation, we didn't have to do anything. We just plug it in. But we can really plug this time. Why? Because this is not given as a standard deviation. So we have to find standard deviation. Sometimes variance is given. Sometimes in the problem, this kind of problem, variance is given. If variance is given, this formula is going to be very useful. You don't have to worry about anything. If a standard deviation is given, you use this one. If variance is given, you use this one. It's easy and simple, right? Now, this time is not like that straightforward. We have to go a little forward here. So we have to know how to find the standard deviation. Well, when you found standard deviation manually, I believe you remember. So that is how you actually did it. So well, standard deviation is equal to square root of SS over n minus 1. Okay, which is a degree of freedom actually. N minus 1 is the degree of freedom. So how do we actually find out standard deviation? All you do is just plug it in. Big square root 90, 42 over n in this case is 8 minus 1. And you take any help from calculator actually. Any kind of calculator is going to work for you actually. So I have this one, TA30 Access Multiview, which is a digital version. So now I'm going to put down second x squared. That will give me, you know, square root, and I just type this in. Well, I can put again a fraction. So 90, 42 over 8 minus 1. Enter. 35.94. So I have 35.94. 35.94. That is what? That is standard deviation. So that is standard deviation clearly. So I'm going to put down here pencil. So that my pencil coming up here, I'm going to plug it in here. Okay, so let's do this. Plug this in. So S sub m is equal to 35.94 over square root of n, in this case is 8 sample size. We don't subtract 1. This time is the sample size is given. So I'm going to actually, again, any calculator is going to work. So I'm going to have this one here, 35.94 divided by, well, I go downstairs, that's fine, divided by second x squared is going to give you square root 8. Enter. 12.71, approximately 12.71. So my estimated standard error of the mean is equal to 12.71, and I would say approximate because I round things up, so I have to say approximately. So that is how we find estimated standard error of the mean. Again, we can do it different way. Let's see, our answer is same. So this one down here to the right side is S squared. How do we find the S squared? So S squared we find SS over n minus 1. That is the formula when we did find standard deviation manually that we learned. This is how we actually find S squared. variance. So well, all we do, SS is given, plug it in. This time we don't use square root because we are looking for variance. So 90, 42 over n minus 1. We can put down 7, or let's put down n minus 1 here so you know what's going on. So that is variance. So variance approximately, let's take a look here. What is the variance here? Comes to play. So I'm going to erase this calculator. 90, 42 and n over d, 8 minus 1, enter. 1291.71. So 1291.71 approximately. So that is the variance. Now once we have our variance, we are going to just plug things in. So that is the variance. You can just plug it in here. Okay, let's see, we got the same answers. So S sub m is equal to square root of 1291.71 over n. This time we don't subtract 1, which is in this case is 8 is the sample size. Now we're going to take the help from the calculator. Okay, so clear here. Second x squared is going to give you the square root and put that in 1291.71 over 8, enter. Look, exactly same thing we found. Look at this here. 12.71, 12.71. We did two different ways and we get the same answer. So we did a good job here, right? 12.71. And obviously that is going to be approximately. So we're going to put down the approximate symbol. Look, both times we have the same answer. I hope you understand when to use which formula, and based on that you adjust and find the estimated standard error of the mean. Thank you.